Hi students, this is Mrs. Myers with a lesson on surface area of cylinders. In this unit, we've been learning about surface area and volume, and we've learned about both of those concepts for rectangular prisms, and we've also learned about volume of cylinders. In this lesson, we're going to look at the surface area of cylinders. So one of the things that we used to find the surface area of a rectangular prism was a net. So we're going to do the same thing with a cylinder. So we drew some nets today in class, but I want us to take a look at the net that's on your handout so that we can discuss how we would come up with a formula for finding the surface area of a rectangle. So if you take a look at the net, you can see that we have a circle here, we have another circle here, and then we have a rectangle. So we have circle, circle, and then the lateral area here, the part that goes around the cylinder, is a rectangular shape. So if we can find the area of those three shapes, we can add those areas together to get the surface area. So let's jump up here to the top and let's talk about, okay, we know that we have two circles. So we're going to click over here, it's two circles. And the formula for an area of a circle, as we explored in our volume formula, is pi r squared. We have two circles. So the formula for finding the surface area of the circles of a cylinder is going to be found by putting a 2. You have two circles, so this part of the formula is 2 pi r squared. And again, if we look at the net, we have these two circles, circle number 1, circle number 2. And since we have two of them, it's 2 pi r squared. All right, well, as you can see, that's not the only part of a circle, of the cylinder. So let's look at other information that we need to find the area of the rectangle. Okay, the first one, the information that I need, is the height. So right here we have the height, and as you know, to find the area of a rectangle, where we usually multiply length times height. Now notice that we don't have the length of the rectangle because it's within the cylinder. All we have is the height. So let's figure out how we could get this measurement here. So if we can get this measurement, we'll have the length of the rectangle. We can multiply that by the height, and then we can find the area of the rectangle. So as we explore this, I want us to look at a website right here. And this website helps us find the surface area of a cylinder prism. So what I'm going to do is let's take a look at this video. And I want you to watch what happens as the cylinder is rolled out to its net. Okay, take a look at that again. So this yellow part would be the lateral area, and then the two circles, you can see them. Let's look at it one more time. So again, this would be your cylinder. The red circle here would be the top base of the cylinder. And then if you watch that red line, watch what happens to that red line when I play the video. Okay, so you can see that that red line right here is going across, and that red line would be the length of the circle. And now we're going to put it back as a cylinder. So let's think about what that is. And if you look over here on the right, it tells us the length of a rectangle will be equal to the circumference of the circular base. Now let's go back to our notes and put all this together. So to get the height of the cylinder, if you notice from the video, and I'll use red just like in the video, this line is going to be equivalent to the distance around the circle. So you saw in the animation, when the cylinder went into net form, this line, the circumference of the circle, the line around the circle, was equivalent to the length of the rectangle. And that would be for both of them. The circumference of this circle, the distance around the circle, is going to be equivalent to the length of the rectangle. So the second thing that we need to know to find the area of the rectangle, besides the height, is going to be the length of the rectangle. The length of the rectangle is the circumference of the base, or of the circle. Circles. Okay, so let's think about what formula that would be. So let's put it all together. So to find the circumference, circumference is equal to 2 pi times radius. That's our formula for circumference. So what that means is the distance across the rectangle is going to be equivalent to the circumference of the circle, which is equal to 2 pi r. So we can put those two things together. We're going to take 2 pi r, that's the length, okay? That's going to be the length of the rectangle. And we're going to multiply that by the height right here, by the height of the circle. Excuse me, of the cylinder. So again, this is the rectangular part. So what we just talked about here is just the area of the rectangle. And what we did is we multiplied the length of the rectangle, which is the circumference of the circle, this 2 pi r h, or excuse me, 2 pi r, and we multiplied that by the height. That's how we got our h. So now we're going to put it all together into one formula. So if we put all this together, the first part of the formula is the two circles, 2 pi r squared. That's the top and the bottom of the cylinder, the congruent bases, plus the circumference of the circle times the height. So that's 2 pi r h. Now we have our formula. So now that we have our formula, we can apply it to the example below. So what we're going to do is we're going to write our formula. Surface area is equal to 2 pi r squared plus 2 pi RH. And again, R is our radius, okay? Sometimes you're going to be given the diameter, and then of course, just like we explored in volume, we're going to have to divide that diameter in half to find the radius. But in this problem, we are actually given our radius. So let's look down here. Let's see if we have what we need. So the radius is equal to 8 centimeters, and the height is equal to 22 centimeters. So all we have to do is plug in those two values into our expression. So where there's an r, we're going to put an r, and where there's an h, we're going to put an h, which is the height. So we can do that right there by substituting 2 pi r. So I put in, as you can see, I put in the 8 for the radius, and then I put in the 22 for the height. So go ahead and write that down on your notes. From here, I can use a calculator, and I can put all this into my calculator. And if I do that, I'll get an answer of 1,507 and 964,000 centimeters squared. And that's going to be our answer. Now, I also want to show you how we can use Desmos for this. Just like when we were evaluating expressions and also solving for surface area and volume of rectangular prisms, we can use our Desmos calculator by putting in the formulas and then telling the Desmos calculator the numbers for the variables. So let's go ahead and have a Desmos calculator out. Open up your Desmos calculator, and then let's try it. I'm going to pull mine up. Okay, so I'm just going to bring it over here, my Desmos calculator, and let's go ahead and try it. So I'm going to just type in the formula as it is. 2 pi r squared plus 2 pi r h. And again, it's not going to give us our answer yet. Maybe I need to make this a little bigger. It's not going to give us our answer yet because we haven't told it the value of r or h quite yet. Let's see if I can make it smaller. It's not going to show up. Okay, I'm going to go ahead and leave this open because we know from the problem the values of r and h, and you have your paper in front of you. So now that we've given the Desmos calculator the formula, now we're going to tell it what the value is for r and h. And so just like our example, r is going to be equal to 8. Okay, and when we tell it that, notice it says we don't know what the height is yet. You need to tell us what the height is, and then we can compute the surface area. So now I'm going to give it the value of h. And h, if you remember from our picture, okay, our h value is 22. So going back to our calculator, we're going to type in 22. And there's our answer. All right, hopefully you practiced that in your Desmos calculator and you recorded your answer on your sheet. So either way, you can substitute it yourself and just write it in like this, and then put the substituted values into your calculator. Or you can just use Desmos, enter in the formula, and then tell it r is equal to 8 and h is equal to 22. So you can do either one of these and you would come up with the same answer. I did round this when I brought it over from the calculator. So you'll notice on the Desmos calculator, the number was a little bit longer. All right, now you've learned how to find surface area of a cylinder. Using a net, we came up with a formula, and you'll be applying this to practical problems in class.